matrices, and it says write the augmented matrix for the system, do not solve the system. So this right here is going to be your system. The system is going to be made up of all these different components. So when you go across, we have a row. This is going to be row 1, and then the second equation is going to be row 2. Then you have column 1, column 2, and column 3. So the way that we talk about the columns is that you're going to have a column of x values, or the coefficients of the x values, coefficients of y, and constants. If you look at your system, this is written in standard form. So your system converts to what we call a matrix. A matrix has the same setup as a system. So it has rows and it has columns. Those are interchangeable terms for each setup of an equation. Move this over. So the way that this works is the system will become a matrix, and the matrix can become a system. It's the coefficients of the x values that make up the first column. Then it's going to be the coefficients of the y values that make up the second column. This line right here is like an equal sign that you see in the linear equations. And then lastly, you're going to have a column of coefficients. So the way that you want your system to look is some coefficient for the x value plus some coefficient of the y value equal to a constant. If you look at the rows of the system, or the first equation, we have a coefficient with x, coefficient with y, and a constant, an equal sign and then a constant. If you look at the second row, we have a coefficient of x, coefficient with y. However, we have this -32. So our constant needs to be moved over to the right of the equal sign. So we're going to need to rewrite the second row before we put it into the matrix. So this is the new row 2, and it was 4x plus 4y minus 32 equals 0. We're going to add 32 to both sides. And now we have 4x plus 4y equals 32. So what I'm going to do is I'm now going to build my new system. I'm going to rewrite it because the equation of the line in standard form is now correctly stated. It has to be x, y equal sign c. So that's what we're going to do. So we're going to have our new system, negative 2x minus 2y equals negative 16. And then we're going to take this right here, our new row 2, and we are going to put it in our new system. So put this all together. There we go. So this is, again, this is going to be the new system. So this system, you can call it whatever you want. Let's just call it system I. So system I is going to go into matrix I. So we're going to put in those coefficients. I'm going to start with the row. So we're going to go x, y, constant. So let's color code this. We're going to go coefficient of x, coefficient of y, and then our constant. So that's going to be -2, -2, -16. And we're going to do this for the second row. Recall that this is row 1, and row 2, column 1, column 2, and column 3. So those are the coefficients of row 2. And then that's the constant. And we're going to write that in. 4, 4, 32. And that's how you augment a matrix. This right here is your solution. Okay, so now we're going to look at number 2. Number 2 has 2 rows and 3 columns. So let's talk about this. This is a system. It's called a system of equations. And we have rows and columns. If you notice in our first row or our first equation, this negative 28 needs to go over to the right of the equal sign. And then in the second row or the second equation, we're missing an x and the coefficient. So we are going to substitute a 0x into the equation as a placeholder, because every single variable needs to be represented by a coefficient in the matrix. We can't leave it blank. So let's go ahead and rewrite these into a clearer system. So when we're looking at the first row, it's going to be 8x plus 9y minus 28 equals 0. I'm going to add 28 to both sides. So now we have 8x plus 9y equals 28. That's the first row of our new system. Then we're going to go ahead and take this, the way that it's rewritten, and write it under here. So then again, we have the new system so that it's set up in standard form. Standard form again is when you have an x, y, equal sign, and a constant. So this is going to be 0x plus 5y equals 20. This is the new system. Then we're going to build our matrix. So the matrix is going to go like this. This is the equal sign. We have row 1, row 2, column 1, column 2, and column 3. An x column, y column, and constant column. We're only looking for the coefficients. Okay, let's look at the first one. What colors we use? Okay, blue, pink, and gold. So it's blue, pink, and gold. So blue is going to be an 8 and a 0. Pink will be a 9 and a 5. And then gold is going to be 28 and 20. So in the first example, I filled the matrix solution or the augmented matrix by rows. In the second example, I filled this in by columns. Both of them are going to give you the correct outcome. So again, if you fill it out in standard form, it would be x, y constant. That would be the row. And then the second row would be 0x, 5y equals 20. Remember, this line inside the matrix is representing an equal sign. And then I want to get back to the dimensions. We mentioned the dimensions, or we measured the dimensions of a matrix. This is the solution, by the way. We measure the dimensions of a matrix in the number of rows, but by the number of columns. So the dimension is going to be a 2 row by 3 columns, excuse me. So then you can just say it's a 2 by 3 matrix. Okay. Number 3, it says write the system of equations associated with the augmented matrix, do not solve. Let's review what the matrix is again. This is going to be an X, Y, and C. This is an equal sign. It's AX plus BY equals C. This is a standard form of a line. So let's go ahead and write the system. I'm not going to use colors this time. We're just going to go across with the coefficients. Please keep in mind that it doesn't have an operation here, but we should assume that they're positive unless it has a negative in front of one of these numbers. Okay, so we can assume right now then it's in number 3, all of these are positive coefficients and constants. So it's 10x plus 5y equals 18, 14x plus 15y equals 16. And this is your solution. This is your system. Number 4, column of x, column of y, column of constants. Negative 2x minus 8y equals 6. 2x minus 9y equals negative 6. This is your system. And then again, this is the augmented matrix. Operations on the given augmented matrix. We are talking about a row operation for row 1. So this is R1, R2. There's 2 ways of representing this answer. You can represent it with the new row, or you can represent it with the new matrix. It just depends on what the homework platform is asking you for, and your instructor. So this says that we're going to take this 1/4 and multiply it by R1. So it's going to be 1/4 times R1. Each of these elements are going to be multiplied by 1/4 individually. So the new row 1 is going to be 1/4 times 4, 1/4 times 2, and then 1/4 times 16. So my new row, I'm going to put it in like a matrix form. This is row 1 new. It's going to be 1, 1/2, and 4. So again, you can also represent this in a new matrix. So what you would do is you would take, you would take this row and replace it with the new row after the operation has been performed. So if you're not clear, this whole new row is going to go and replace this row 1 right there. Okay, so it's like you're picking it up and replacing it. So this is what it's going to look like. So this is an acceptable answer. And again, a new matrix is also an acceptable answer. So it's going to be 1. Oops. It's going to be 1, 1/2, and 4. That's the new row 1. And then you keep the original row 2 because we didn't do any math operation to impact the second row. So it's going to be 4, 2, and negative 4. Both of these, again, are acceptable answers. And you replaced row 1 in the new matrix. Like a compound steps, like we have multiple steps to create the new row 2. So for number 6, it says row 2 is equal to, so we're going to change this row right here. The new row 2 is going to be equal to a -1 times row 1, and then we're going to add that to row 2. So let's see what this looks like. Again, you can present your answer as a new row or a new matrix. You have to be familiar with both. Okay. So in this case, it's going to be -1 times row 1. So it's going to be -1 times 1, -1 times 2, and -1 times 10. And then we're going to add that to row 2. So row 2 is going to be 1, 5, and -3. All right, so let's see how this works. When we add, we're going to add going down. Just want to bring that up. So altogether, it's going to be -1 plus 1 is going to be 0. And then you're going to have -1 times 2. So -1 times 2 is -2, plus 5 is 3. And then you have -1 times 10 is -10, minus 3 is -13. Now, this is an acceptable way to present your answer. Or again, you can do the new matrix. So we are replacing row 2 with the new row 2. So we're going to keep, we're out of colors. We're going to keep row 1. So our new matrix is going to be 1, 2, 10, and then 0, 3, -13. Either one is an acceptable answer. You kept the same row 1 and you replaced the row 2. For number 7, it says use Gauss elimination system of equations, find the arbitrary y. Okay. All we're going to do is enter these equations of the system and look for the point of intersection. So the point of intersection is where the lines cross. We're just looking for that. Given the solution of arbitrary y, I don't have that in the assignment. So we're going to enter it the way we see it. It's going to be 2x plus 3y equals -5. And then it's going to be x or 1x, just depending on who you ask. It's the same thing, minus 2y equals 8. And then we graph these. So we're going to look at the app all together. One of the lines is blue, one of the lines is red. We cannot see it on this table, so we're going to press the home key. And right here, if we touch, remember this is touch screen. This is the point of intersection, so it's going to be 2, -3. So since that's the point of intersection, here's what this means. When we go back to our notes, that means that 2, -3 is a solution to this equation, which means that x equals 2 and y equals -3. This line, 2x plus 3y minus 5, intersects with line 1x minus 2y equals 8. And that is how you find the solutions for the systems of equations without a matrix operation or Gauss elimination.